Hi, I'm Sandi Besen. I'm an AI engineer and ecosystem lead at IBM Research, and we're going to talk about building reliable agents and what that really means and how our open source framework BeeAI helps you to achieve that, and then also show you the platform piece of the open source application where you can take your agents and bring them to life with a UI. So the first part I want to get into is why we even decided to build this, right? Like, what's the point of building another agent framework or another application? There needs to be some value that it's providing beyond the other, 5 alternatives in the equation, right? So first of all, it stemmed from our internal needs, which often as a research organization, things do. You look at what's out there, you say, okay, I needed to do something just a little bit differently than it does. And so let's make it, right? Let's see if it sticks. Let's invest in it and see if everyone else wants to use it as well. So the first reason is that agents can be very messy to create, especially reliably, and enforce them to follow certain patterns or rules beyond just guiding their behavior by adjusting the system prompt or things like that, right? The second is, okay, once you have an agent, what makes it production ready? What are the features that it needs to have built in, like caching and serialization and memory optimization strategies that allow it to actually run efficiently in production? And thirdly, once you have this agent, this script, right, how do you actually show that to the end user easily without needing an entire full stack team to stand up the infrastructure for an application and build out a design, when a lot of these things tend to be quite repeatable? We've all seen a lot of chat interfaces. How many chat interfaces are there out there? Why do you need to create your own chat interface? Right? That can be provided for you. Things like ingesting things in forms, and so we'll see that today. And I like to make these sessions a little bit more interactive, so there's a lot of content we can cover, and I'll use maybe like a survey of people to see what they're interested in, and then we can go deeper into that area. Does that sound okay? Cool. So we talked a little bit about this, but there are 2 major sections of BeeAI. There's the framework, where you do the agent building, right? And then there's the platform, which is for the end user, where you make your agent available and share it with your teams and others. So we'll go over both of those today. First things first is, as is everything here, we are open by design, and we are part of the Linux Foundation, so we are committed to being open. We actually had our community call this morning, so if you're interested in joining our community, whether it's contributing or just hearing about the updates that we have monthly and other contributors that have built cool projects, we highlight those on the community call every month. So we'll go into a little bit about the foundations of the framework, but then I'm actually going to show you. So we'll cover some slides, but then I want to demo some stuff. I want to dig into some of the code a little bit. So firstly, the BeeAI framework is a multi-agent workflow. It enables you to build multi-agent workflows. It also, and this is where we focus, it allows you to build agents with constraints. So I'll go into more what that means and how we do that. We have declarative orchestration, which means that we can define in YAML. So you can either build using Python or TypeScript, we support both, or you can configure in YAML. We have pluggable observability, so we use OpenTelemetry, and we can integrate in with things like Phoenix Arise or LangFuse, or however you decide to do observability for your agents. Like I said before, we have both Python and TypeScript, and something that is, everyone has MCP at this point. I think everyone is used or implemented MCP at this point. But we're also using A to A, so we have A to A extensions available in the framework that make it a little bit easier to work with Google's agent-to-agent protocol. How many people here have tried A to A or experimented with A to A yet? Okay. How have you found that experience so far? It's good, yeah. But could be a little bit easier to work with, right? There's a lot of stuff going on, yeah. So we've taken that, we've simplified it a little bit and abstracted it, so it's a little bit easier to work with, but it has the same underlying implementation. And you'll see that if you're interested in following, I'll leave this on the screen for a second. This is where we would post stuff. This is our GitHub. Okay, I see most phones down. Okay. Oh, sorry. I'll go back for a second. Okay. And so that's a bit about just an overview of the framework, but we're going to go into how we actually enforce reliability in a moment. But I want to cover the platform briefly first. So like we said, you have a script. Now, how do you actually provide that to the end user quite easily? How do you share that within your organization? So we have a platform that you can either run locally, or you can stand up behind your VPN, and you can share agents to it. It has an instant UI, which you'll see in just a moment. We have the typical chat UI. We also have other UI features like forms and citations and trajectory that are very important when creating an agent, so you don't have to recreate the wheel, and it's basically just a little bit of metadata that you add to the top of your agent, and it pulls in those components for you in the UI. We have a very easy deployment, so I don't know how many people who have suffered through containerizing their agent and bringing it onto an application, but it can be quite a lengthy process. We've tried to streamline that as much as possible. You have a URL to a GitHub repo, you can add it to the platform, and that is it. It does the containerization for you. It is quote unquote magic, right? Or you can run it locally, the agent locally, and automatically it will be registered to the platform if you're running it locally. We also provide a bunch of different providers. So we have 10 plus providers out of the box that we provide on the platform. You can use OpenAI, Anthropic, Gemini, whatever you want to use, including local with Ollama. And lastly, it's framework agnostic. So although we have the BeeAI Framework, where we encourage you to build because we can encourage some of that reliability, you don't have to. You can use LangGraph, LangChain, Crew, AG2, whatever you want to use, you can build with that and bring it onto the platform because we use A to A, so every agent brought onto the platform is an A to A agent at the end of the day. And then as I put this up on the screen, if anyone's interested, I'll just pause if there's any questions so far. If not, I'll just continue on and showing you all. Yeah, the platform deployment.
And regarding, let's say, maybe I'm jumping the gun, so I'll let you finish.
Okay, sounds good. Okay, so let's see some demos. I'm gonna play. There's no audio.
Are you going to sing along?
Yeah, I can sing it. Okay, I'm gonna skip the first part, but I wanna show you guys a few things. I'm gonna show you the platform first. So you can see the type of agent or type of UI that you can build. This is actually the Granite Playground. It enables you to use all Granite models, and it's public, but it's using the BeeAI as the UI or the platform behind it. And so this went a little quickly. I'm gonna back up. So you have things like you can select different methods if you want to do search or research, as in deep research. You can see that it has trajectory, so what is actually happening behind the scenes. This is producing its first thing, which is a research plan. It's searching for information, so here's all the sources it's searching for. Now it's doing its research. And when I actually get a final answer, this is a little quick, but I'm going to scroll to the bottom. And I'll see that it generated 23 sources, right? And I'm able to capture this with OpenTelemetry, and I'm able to put in some metadata that says that I want to capture my sources and I want the sources to be featured on the front end. And it's generating citations. And if I click on the sources, I can actually see as well all of the sources as you would on an OpenAI or a ChatGPT or a Claude. But I don't have to recreate the wheel, right? There's UI components for this that exist. But that's not the only way to interact with things. I can also interact, that's chat-based way, right? Here on the left, I'm running an agent, so this is being locally run. So you'll actually see things happening. It's registered to the platform just by running the agent because I was able to put a serve module in there that our framework provides. And so it's automatically registering into the platform. And I have things like, this is actually an agent that helps you prep for upcoming conferences. And so I ask it a task. I'm planning on meeting the rep at the next conference. Remind me where we left off on previous discussions. So I'm able to say the company is Moderna. I have things like radio buttons I can add, multi-select, event dates that I can choose. And then I have similar features. Slightly different implementation, so slightly different UI. Here I have like the accordion where I can see the actual code. But I can see trajectory. I can see that it's executing, it's thinking, it's doing a vector store search, it's thinking again, which means that it's having that React pattern. It's doing internet search for DuckDuckGo, and then it says, okay, I have enough information. And it provided a final answer. So that's a little bit about the platform. I'll just stop for questions in between, and then if no questions on this, I'll move on to the reliability piece of the framework.
Do you have a workflow composer written as part of the framework?
As part of the framework, yes. Yeah, not as part of the platform. We keep the orchestration piece on the framework side for right now. Something we're exploring, to be honest, as well. And if you think that there's a reason to have it on the platform side, I encourage you to like open a discussion, and then we can talk about whether it makes sense to have it additionally on the platform side. And especially as we're thinking about agent interoperability. For instance, like you have maybe an agent that's brought onto the platform that is a lane graph agent, and then you have another Crew AI agent brought onto the platform, and we're talking about like on-demand discoverability of agents. That's something we're exploring is like, now where does that orchestration sit? That orchestration doesn't always sit at the framework layer. That's like almost like another middle layer.
Yeah.
Yeah, so, and that's something that I think the industry hasn't moved on to yet, but it's coming in the next 6-ish months, I think.
Does the platform or framework have any built-in security controls for agent action and otherwise?
The framework does. The platform, it's relatively lightweight, so we would encourage someone who wanted to deploy it to do security and auth on their own.
Thank you. I was wondering if the framework itself has any features that allow you to define data signatures if you're using agents to extract data, say, from scientific papers or financial documents. I'm thinking something like DSPy.
Can you define, can you give me an example of?
Yeah, so say you're building agents to extract clinical data or clinical trial results from papers, and so you can define a data signature of a clinical trial endpoint, which is kind of a measurable clinical data or biological data that has a statistical significance, has multiple other attributes, and then you use that data signature to extract all of these instances. And I've found DSPy to be helpful with that, and I was wondering if that's kind of built into the framework.
I don't see why you wouldn't be able to, as long as you could pass anything into citations or trajectory that you'd want to. You just have to log it somewhere, right, or keep it somewhere persistent for it to collect or be passed. But technically, you can edit any of the stuff on the front end to pass whatever you'd like into it. There's just more common patterns and less common patterns. Cool. Okay, with that, I will move on to the framework side. So I'm going to show two things as we talk about agent reliability. One is this blog piece that I wrote just a few weeks ago, and it talks about this agent abstraction that we have called the requirement agent, and this has become our base or main abstraction of agents because we believe it's important for every agent to follow requirements. And so in this requirement agent, let's say we have a workflow that looks something like this, right? And it's actually not that complicated of a workflow when we read out the rules. Like, it must think first. The weather tool must be used at least once, but not consecutive times in a row. And the agent can only search the internet once it has gotten the weather at least once, right? These are things that I think most humans would be able to follow directions, especially if we're only talking about 3 tools here. But when we actually map that out in a mermaid diagram, it looks something like that. And that's absolutely not impossible to do. But to enforce the agent to follow certain requirements takes a lot of orchestration code. And so the way we do it, and I actually made a comparison here. So I'll show you first the way that we do it, and then I'll show you next how we did it in LangGraph. And I love LangGraph. LangGraph is great. But we tried to simplify similar processes that you can do in other frameworks. So it's a little bit better for experimentation, and I'll show you why in just a second. So first, we just have our imports here. We have our requirement agent class. We're using OLAMA. And then we have our tools. So we have our think tool, which is essentially a tool where we encourage the agent to follow a React pattern to do some planning before it calls a tool. And we can enforce this in certain patterns, making it a loose React agent or a strict React agent where it has to do this between every tool call or just at the first tool call or in between every other tool call, right? We can be a little bit more flexible without having to rewrite the orchestration logic every time. Then we have our our weather data tool. Then we have our internet tool. And we have very simple instructions, right? Like plan activities for a given destination based on current weather and events. So here's where our conditional requirements come in. So instead of having to write all of the orchestration logic like you saw in this graph, right, and capture the state and see how many times this has been called and has this been called before this or after this, you don't have to deal with any of that because it's already implemented in the framework itself. So we can just call requirements on the tools. Like for the think tool, we must force this at step 1. Okay? Now for the DuckDuckGo search tool, we can only call this tool after the OpenTelemetry tool has been called. Now because there's only 3 tools, this does force a certain workflow, but if we had 5, 6 to 10 tools, right, this would be a little bit different. This would be more flexible. And you can make the rules as flexible or as strict as you'd like to make a very strict workflow, or just give a little bit of guidance to the agent, but know that it has to follow these because it's not a suggestion, and you'll see why in a second. Okay, and let's say minimum invocation. So we want this tool to be invoked at least once. And same for the OpenTelemetry tool. But I don't want this to be called consecutive times in a row. And this must be invoked at least once. And if you've played around with a lot of agentic systems, you might notice that they tend to think they have the information that they need, maybe prior to the fact that they do have the information that they need. And so I find these things like minimum invocations or consecutive allowed very powerful without having to spend much time implementing that. And if I want to change these things, I can, we have a ton of, you can set your own custom requirements. There's a ton of patterns that can be found here, I think. Oops, sorry. Here's the complete parameter reference. So we have a ton of them here. We have force at certain steps. We have priority in case there are certain rules that conflict. It can choose which rule takes precedent. We have prevent stop, so this tool cannot call the final answer tool. All sorts of different tools. And then we run the agent, right? So the question was, what do you do in Boston? But how does it actually work? So we have these conditional requirements where we set them on tools. And typically, we have the pattern of an LLM being used as the reasoning ability to decide what tool to call next. And that's still the case here, but instead of just allowing it to have access and see all of the available tools, we are only allowing it to have access and see the available tools that, based on your business logic, you think it should in that invocation, right? So in a certain step, maybe it has access to see all of the tools, but in the next step, it might only have access to see one of the 3 tools, and therefore you are forcing it to choose the tool that it should call in that instance. So it doesn't take away the reasoning ability of the model, it just doesn't allow it to see what it shouldn't see or what it shouldn't choose out of the box. So it actually preserves some of the reasoning ability of the model in that case. And so I want to get into, I'll stop for a couple of questions, and then I want to get into one other piece, is the middleware piece. And this is where you can plug in things like security and guardrails and getting onto that topic earlier of how do we enable you to build these things into an agentic system, but without using the LLM to actually call them as tools. So any questions on the requirement agent and agent enforcement? Cool. Okay. I'll move on then to the middleware piece. So I'm going to walk through one example of the middleware piece, and this is using content filter. So this is a very simple content filter. It's a keyword. Right, so if we just, here, go from the top. And this is all in the examples, it's all in the repo, so you can run any of this. And at the end, if you'd like to get started with the framework, there's a great hands-on workshop that is an introductory to the framework that covers a lot of the main aspects of it. I haven't added the middleware piece in yet, so I will do that sometime this week. But it's a good starting point if you want to explore like caching, serialization, memory optimization strategies, and a lot of people have said that they have used it not just for BeeAI Framework, because these concepts are applicable for any framework that you use. So with that, I'll get quickly into the content filtering piece. So here we have our content filter class, middleware class. And so I'm just creating the content filter itself, right? So I'm certain words like inappropriate, I think crap was one of them. And so it's creating the content filter itself, and you could sub this out for a model or an algorithm like Llama Guard, or you can use LLM as judge here, or you can use all of these other ways, but essentially instead of having a model run and then say, okay, now I need to call a content filter, like that depletes the purpose a little bit, right? You should catch these things before they even go to the LLM call. But sometimes you don't want a strict pipeline either, or you want to catch them upon certain events that occur. And so we can hook in here to the emitter for all of the events, and you can create custom events and things like that. And so here we have our requirement agent, like you just saw. We have our LLM. We're using a type of memory called unconstrained memory, which just means that there are no limits on the memory. And that's one of the few optimization strategies we have. And then we are using our content filtered middleware. And these are our banned words, like crap, inappropriate. And then we have the custom response that we can provide, saying, I understand you're frustrated, but I can only help with appropriate requests. How can I assist you today? So same thing here if we wanted to do something like prompt injection, right? And so if we run this, then, and we say crap, we should get this custom response back. But it doesn't actually go to the agent at all, because upon the emitted of the event, this is automatically ran, right? So as we think about putting agents in production, this is one of the key things that we're finding, is that these middleware components are becoming increasingly important, and we're seeing other frameworks follow suit, like LangGraph also has a large middleware component now that they, I think, came out with a couple weeks ago. And so this is going to be a trend that we start to see, is once we've figured out how to build these effective agents in POCs, and there's time to come to production, and you need to build all of these pieces around it, implement prompt injection, guardrails, custom checks, and things like that. We don't always want to do so at the agent implementation. Sometimes these things are done before the agent is even ran, or after something is ran. But you don't necessarily want to create a strict pipeline either. So this is a really good way to hook into any agent-emitted event. Okay, and I think that's all I have for you today. I'll leave this piece up. This is the workshop if you're interested in an introduction to the BeeAI framework and getting started. It's a Colab notebook, doesn't require any setup. It's great to run through, and you get to build the conference agent that we saw in the demo. Actually, I'll put it here because this is a little bit better instruction. Okay.
Do we have any
With
final
that,
questions for Sandi?
Questions? A couple minutes left.
All right, looks like we got through them during the session.
Great.
All right, thank you very much,
Thank
Sandi.
you.
Thanks, Sandi.